Hi there everyone, James Morse again here. Following my earlier video about the Spitfire wing design, today I'd like to talk briefly about another Spitfire subject, and that is longitudinal stability, or the stability of the Spitfire in general. Now this does sound like a rather dry subject. It did have quite a big influence on the development of the Spitfire and its operational limitations. The Spitfire had one drawback: it was with longitudinal stability. By this I mean the aircraft oscillating back and forth along the longitudinal plane of the aircraft, following an input of either air turbulence or a movement of the elevator controls by the pilot. And aircraft fall into various categories in terms of stability. Either you can have a very stable aircraft, or one that is just stable, and aircraft that are inherently unstable. An inherently unstable aircraft is one where you would get fore and aft oscillations of the aircraft to the point where those would increase rather than decrease over time, regardless of pilot input. A compromise has to be reached. Too much stability means that the aircraft would be sluggish to respond to the controls, and not enough stability would mean that the aircraft would be very difficult to control and to aim the guns onto a target. Obviously an interceptor fighter has to be very nimble and fast on the controls, but not to the point where the aircraft is going to become unstable. The main factors to be considered with longitudinal stability are the centre of gravity of the aircraft, or its weight distribution, and what is known as the neutral point. The neutral point is the aerodynamic centre of the aircraft when in flight. For stability, the centre of gravity has to be forward of the neutral point when in flight. If the centre of gravity and the neutral point are together on the aircraft, then the stability becomes marginal. If the centre of gravity goes further rearward of the neutral point, then the aircraft could become dangerously unstable. In my first video, I mentioned that the design team had decided upon a single spar, and that spar to be at 90 degrees to the longitudinal plane of the aircraft. For reasons of centre of gravity, the main spar was attached to the fuselage just behind the engine and in front of the fuel tanks. This resulted in the Spitfire wings being set very well forward on the fuselage and contributed to its brilliant and nimble handling characteristics. Now, with the centre of lift pressure known to be at quarter chord from the leading edge of the wing, consequently we have the centre of gravity very close to the neutral point aerodynamically of the aircraft. The result of this was that it limited the ability to load extra equipment aft of the main spar without consequently making the aircraft dangerously unstable. Beverly Shenstone, the aerodynamicist for the Spitfire, concentrated on making the aircraft as aerodynamically efficient as possible, and consequently he designed a very small tailplane for the Spitfire. The original Spitfire tail fin was quite small and in fact had to be increased in size to what was then known as the broad chord fin to cope with the extra power of the later Merlin 66 or 60 series engines that were used in the Mark 9 Spitfire. More importantly still was that the horizontal tailplane was relatively small, and this really perhaps was the main cause of the lack of stability, in that it wasn't able to damp out the forward and aft oscillations of the aircraft. My own view is that due to wartime pressures, this wasn't really properly addressed until really late on in the development of the Spitfire. The later Griffin engine Spitfires had what was known as the spiteful tail, which had a larger area of both horizontal and vertical fins, which really finally solved the problem of this longitudinal stability. Earlier on, the RAF got into really big problems with the Mark 5 Spitfire, and there were some instances of aircraft breaking up in flight, and Geoffrey Quill, the Supermarine test pilot, was sent to some squadrons to investigate this problem. and found that actually a number of the squadron aircraft were dangerously unstable. And it transpired this was really due to the loading of ancillary equipment too far back in the fuselage behind the pilot, causing the aircraft to be dangerous to fly and to become inherently unstable. All of these instability problems had a big effect on the operational limitations of the Spitfire, and whilst it was an absolutely wonderful interceptor fighter, it always had a problem with range. The problem was that you could not add extra fuel tanks behind or beneath the pilot because the aircraft would become unstable, and so a variety of types of drop tanks were used to extend the range of the Spitfire. Now this started to become very urgent when the United States Air Force carried out daylight bombing raids over Europe and could not be escorted all the way to their targets and all the way back. And it was really solved by, as most people know, by the introduction of the North American Mustang, which had a much longer duration than the Spitfire and was aerodynamically a wee bit more efficient. And the reason it was more efficient was it had a semi-laminar flow wing and an absolutely brilliant fuselage mounted Meredith effect radiator, which reduced the drag of the radiator by up to 90%. Now, probably thinking about it, the only mistake perhaps Mitchell made in the design of the Spitfire was to locate the radiators under the wings rather than on the underside of the fuselage. The wing-mounted radiators caused turbulence. They also were not in the prop wash, so this was then a problem in terms of taxiing, that the Spitfire could overheat because it wasn't getting enough air through the radiators whilst on the ground. Ironically, of course, the photo reconnaissance Spitfires had wonderful endurance, and obviously the reason for that was that the guns had been removed from the wings and the whole leading edge D section of the wing became fuel tanks. This was an absolutely ideal location for the fuel tanks in terms of stability of the aircraft. And in fact the later Mark 8 Spitfire, which again oddly enough was a later aircraft than the Mark 9, that also had wing root tanks to extend its range. Most of those Mark 8 Spitfires actually went and fought in the Far East theatre and the Middle East, and so not over Western Europe. When the two-seater trainer Spitfires were developed from Mark 9 Spitfires at the end of the war, to attain adequate longitudinal stability, the front cockpit had to be moved forward by 13 inches. This necessitated much reduced tankage in front of the pilot, and again, as with the photo reconnaissance Spitfires, the fuel was then carried in the leading edge of the wings. So there we are. The Spitfire had very few vices, but unfortunately one of them was this rather delicate longitudinal stability, which dogged the aircraft throughout most of its service life and did limit its use to short fighter sweeps, but never really made it as a long-range escort fighter. If you've enjoyed this video, please like it, and if so, leave a comment below. Click the button below to subscribe to my channel and look out for any future videos, and thank you for watching.